Guys, good evening all. This is the session which helps you to understand about the timing diagram in microprocessor 8085. So in the previous classes and all, we studied about the microprocessor architecture, pin diagrams, addressing modes, etc. Now we are going to study about the timing diagram. That is how the processor fetches the instructions and how it executes. First, you have to know about what is timing diagram, instruction cycle, machine cycles, and all. The timing diagram, simply we can say that it is a graphical representation which represents the execution time taken by each instruction in a graphical format, which helps you understand in simple manner. The instruction cycle means it is the time required to execute an instruction, and the machine cycle means the time required to access the memory or input-output devices. What the T state means the machine cycle and instruction cycle takes multiple clock periods. A portion of an operation carried out in one system of clock period is called as a T state. So the graphical representation of one T state will start from the falling edge, which is also called as negative edge, to the next falling edge. So the T state will always start from the falling edge of a cycle and it will end in the next falling edge. So this is the graphical representation and diagrammatic representation of the single T state. So in the timing diagram, the various machine cycles are available. So the 7 basic machine cycles are opcode fetch cycle, which consists of 4 T states to 6 T states. The next one is the memory read cycle, memory write cycle, likewise input output read cycle, input output write cycle, the interrupt acknowledgement cycle, and the bus idle cycle. So this is the tabular column which shows the status of the input output memory, and then status signal 1 and the 0. And then a number of machine cycles which is needed for each machine cycle. And the control during this opcode fetch cycle, what about the read, and during memory write, what about the write signal and all, which is mentioned here. This tabular column is very much important. This will helps to understand the timing diagram. Next. In the timing diagram, these parts are available. That is, in the timing diagram, we have to mention the higher order address bus, lower order address and data bus, because the lower order address and data bus are already multiplexed. That is AD0 to AD7. The higher order address bus mentions that the A8 to A15. The address latch enable signal, read, write, input, output, memory signals. So this is the opcode fetch cycle. As already we discussed, the opcode fetch cycle has minimum 4 T states, or it has 6 T states. Here I am mentioning the 4 T states. Apart from the opcode fetch cycle, remaining cycles have 3 T states. So the first one is the clock signal. See, here the T state starts from the one falling edge to the next falling edge. It completes in the next falling edge. So in the next higher order address lines are given, that is A8 to A15. It starts from the T state 1 and it ends here. So in the T state, after the T state 3. So the next one is the lower order address bus. That is, it is the combination of address lines and the data lines from 0 to 7. So at the starting, when this is executed with the help of the address latch enable signal. At the time of starting, both are multiplexed. After the enabling of address latch signal, that is address latch enable signal, when it is enabled, the address bus and the data bus gets detached. So it individually split into lower order address, that is A0 to A7, and here the opcode D0 to D7. It gets detached when the address latch enable is active. So the address latch enable signal will be active throughout the process. Come to the input output memory and status signals. During the opcode fetch cycle, the input output memory is 0. Status signal S1 is equals to 0, S0 equals to 1. The read cycle is enabled when the data, that is data bus D0 to D7, we have to, that is, we are fetching from that opcode. So we are having an instruction. So while discussing the example, it will be easy. For a single opcode, for a single instruction, we had a opcode, right? After that, the address or a direct data will be given. For that single instruction, the opcode is getting here. So it is called as opcode fetch cycle. So we are reading the signal. We are not writing anything. We are reading the signal. We are getting the opcode for that particular instruction. So the read signal is enabled here during the D0 to D7. So this is the opcode fetch discussion. And memory read cycle means when we are, it's the same as the opcode fetch cycle with the changes in the status signals. S1 is equals to 1 and S0 is equals to 0. The higher order memory address, lower order address, again it gets, when the address latch enable is started, the data bus gets detached and it reads the given data. This is memory write cycle. Here the write signal is enabled. In the previous one, read signal is enabled. So this is read signal and write. So come to the instruction, that is an example for a timing diagram. Here we are considering move A comma B. So it is, as you already know that, for the move A comma B instruction, we are having a single opcode, right? So this comes under the opcode fetch cycle. That is from the memory to the 8085 opcode fetch cycle. So it has 4 T states, T1 to T4. As in the instruction, the opcode is in the second one, that is higher order address lines. Here the address given is A000. So the higher order address line is 00, lower order is A0. The 78 is getting in the data bus, address latch enable is enabled. So in all the memory timing diagrams, the read signal and write signal will be present. Based on the instruction, we have to decide either it is enabling or disabling. So this is the first example. Come to the next one. In this example, it has both the opcode as well as the opcode fetch as well as the memory read cycle. So first 4 T states comes under the opcode fetch cycle. The next 3 states will comes under the memory read cycle. So we are getting the opcode value for the instruction as well as for the data memory read cycle. So this is the timing diagram for that, the combination of the both. So these are all the examples. Further, I am giving a this is important, that is store the value in the accumulator. So it has 4 cycles, that is opcode fetch cycle, memory read cycle, memory read as well as the memory write. So this is the complete timing diagram for that store operation. That's all. This is the basic information and explanation for the timing diagrams and its basic machine cycles and example for the each thing. Thank you all. We will see in the next class with some other topic. Thank you.